Hi, this is Jason Baker, and welcome to our weekly lecture on DevOps and cloud infrastructure. This week, we are going to talk about serverless technologies. And serverless is a relatively new lecture that I've added to this course. And over the past couple years, the use of serverless has absolutely exploded. It represents a revolutionary transformation in the way that we build and deploy our applications. We can build our applications using functions essentially. So it's what we call function as a service. And we build our applications using these small functional building blocks. The functions then are managed by and executed by a service provider, freeing us up from the drudgery of having to manage infrastructure resources. Let's take a look at the agenda for this lecture. Now, this is really going to be a jam-packed lecture covering quite a bit of content. First of all, I'm going to talk about serverless technologies and help you understand sort of at a very high level what serverless applications look like. And then I'm going to talk specifically about Lambda, which is the computing component of a serverless platform. And Lambda is a managed service provided by AWS. We're going to look at how Lambda functions work, some of the important performance considerations of Lambdas, how you actually go about programming and building a Lambda function, and I'll wrap things up talking about versioning and some of the best practices around building out Lambda functions and serverless environments. Then later on, in the sort of the second part of the lecture, I'll cover a couple additional services which you oftentimes find used in combination with Lambda functions, notably API gateways and DynamoDB databases. And then finally, I'll end the lecture by covering some of the different frameworks that are available to help us build out serverless platforms, CloudFormation SAM, and some of the serverless frameworks which are available in the marketplace. Okay, let's jump into serverless. So Jeff Bezos was made a famous quote a number of years ago, and he said, "There's a lot of undifferentiated heavy lifting that stands between your idea and its success." Well, what did Bezos mean by undifferentiated heavy lifting? Basically, what he's saying here is that if your organization wants to build a new software platform, oftentimes there's a lot of things that you need to do in order to build that platform. You have to, potentially like configure EC2 instances and manage those instances and set up your software services to run on those instances. You have to configure database systems and you have to manage the database servers. You might have to set up like a proxy server in your environment if you need to support an API. There might be dozens, maybe hundreds of different things that you need to do to deploy a new application platform. And the reality is that, you know, other than the unique code that you write for your application, that unique business code, pretty much everything else is just sort of configuration work. And that configuration work is the same. You're following the same processes that thousands of other companies have to do in order to launch similar sorts of platforms. And so the work that you're doing to actually configure the infrastructure and configure the application services, that's undifferentiated heavy lifting, meaning that it's no different than the work that everybody else has to do. And so it's not actually adding any sort of competitive advantage to your organization. It's not offering any sort of unique value. And if there was a way to build your platform without having to do all that configuration work, well, then you could potentially build your platform faster. You could increase your service velocity and likely also improve service quality because you're not having to focus on that stuff anymore. Now you might be thinking, well, AWS offers all these different managed services, and so you can use like the relational database service instead of spinning up an EC2 instance and deploying your own database software application to the instance and managing it. That's true, but there's still some work involved in sort of managing the database service, at least from an application standpoint. You might have EC2 instances that you need to manage. Even if you build containers, you still oftentimes have to sort of manage the environment that the containers are running in. So what if there was a service available that sort of freed you up from having to do all that work, where as an application developer, you could focus on writing code and then deploy that code to a service provider, to a cloud provider like Amazon, and Amazon figures out how to run it for you, figures out how to run and scale your application. That's kind of the notion behind serverless and Lambda functions. So in a serverless architecture, we use a cloud-based architecture and we leverage event-driven programming models. What does that mean? Well, what that means is that we're no longer managing any sort of compute infrastructure or operating systems or even application servers. We don't we don't we don't worry about any of that stuff. We we create functions and we focus on sort of the overall design of our API and our database schema, and we can connect those pieces together using different serverless architecture components. You can think of serverless architecture as being somewhat similar to platform as a service, but it's a less opinionated form of platform as a service, versus things like Elastic Beanstalk or Heroku. Oftentimes we call this function as a service. Now, the name serverless is sort of a misnomer because, if you're going to write application code, that application code has to run on a computer. So it has to run on a server somewhere. So a serverless architecture isn't truly serverless, but we call it serverless because we don't really have any understanding or awareness of where the code is actually running. It's simply not a concern of ours anymore. We can write the code, our application code, we can push it up into the serverless platform, and that application code will run and sort of magically scale. When you think about traditional applications rely on long-lived server processes, that are running maybe as part of a service, a package that's installed on an EC2 instance, or it's running as part of a container. But the key here is that there's some service in the background that's always running, that's always listening and waiting for requests. It's kind of like an Nginx or Apache web server that you install on an EC2 instance. That service is just going to sit there 24 hours a day waiting for requests from customers. Serverless architectures are fundamentally different in this respect. In a serverless architecture, an event triggers a function. An event triggers that service. So the service only runs for a very short period of time. It's not continuously running. It's waiting for events to occur. And so a customer browsing to a website with their web browser, the request that they make to that that to that web service is actually going to trigger something like a Lambda function, which will then handle that request. It might go out and then communicate with the database and provide a response back to that customer. But after that Lambda function handles that response, it's going to die. It's going to terminate quickly, and then another request is going to trigger the execution of that Lambda function. So there's no service on the back end that's continuously sitting there running and executing work. The functions are only executed as part of some sort of event. And oftentimes in a serverless architecture, we move the application flow control from some sort of server side system into the client application itself. So now the client application, it could be like an Angular or React based application. This 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 client side application now controls the application flow, and it's responsible for reaching out and communicating with different cloud based services. What does that mean? Well, from an application development standpoint, then I might heavily leverage third party services and move much of my business logic into those third party services rather than trying to build that logic myself. You know, there's no need for me to build something like an identity management service, a service which handles the user logins and user password resets and user account creation and so on. There's no need for me to build that service when there are lots of third-party companies which provide that service, and I can easily hook my application platform into that service. That allows me and that allows my application development team then to focus on the critical parts of the application which provide business differentiation and value to my particular customer base. So the first serverless component that I wanted to cover in this lecture and where we're going to spend the majority of our time this week is on AWS Lambda. Lambda is a computing service which runs your application code on demand. It's triggered by different events. And the cool thing is that it's completely managed by AWS and it will scale automatically without the need to provision or manage any sort of servers. When you're working with like EC2 instances and running your application on EC2, you can leverage a service like auto scaling to automatically scale the number of EC2 instances up or down. But there's some work involved in setting up the rules and testing that sort of service. With Lambda, you write your application code, create a Lambda function, and that Lambda function, AWS takes care of automatically scaling your Lambda function for you. With Lambda functions, you are paying for the compute time that the Lambda function consumes. So you only pay for the amount of time that the Lambda function actually runs. You pay for that time in 100 millisecond increments. And again, AWS Lambda functions follow an event-driven programming model. So Lambda functions are not running continuously. There's no, when you write your Lambda function, it's not like a service that's sitting in the background just waiting for requests. The Lambda function will only execute when it's triggered by some sort of an event. And you get to define what sort of event will trigger your Lambda function. Well, how would you or why would you use Lambda functions? And what can you do with it? Well, there's all kinds of things that you can do with Lambda functions today. You can build out RESTful APIs and complete web applications. using Lambda functions. I'm working with an organization today, at least at the time that this video was recorded, that's building out a complete and large scale healthcare application that is predominantly based around Lambda functions. You can use Lambda functions to build data analysis and data transformation pipelines. If you have an application that is ingesting large amounts of data and you need to perform some sort of analysis or transformation on that data, you can ingest the data and then push it through a Lambda function, and the Lambda function provides you with all the sort of data analytics functionality, and then output the resulting transformed data into something like maybe an S3 bucket. And then finally, you can use Lambda functions for automating administrative tasks. And I've used Lambda functions extensively for this purpose. When you're using something like a CloudFormation template to deploy a set of resources in an application environment, sometimes there are things that you just simply can't do using the standard CloudFormation resources. And so if you need to do something in a CloudFormation template that you cannot do in a standard resource definition, you can create what's called a custom resource. And a custom resource will call a Lambda function. And inside the Lambda function, basically you can do just about anything you want to do because you have full access to the AWS API. So the Lambda functions provide you with a way to significantly extend the capability of your typical CloudFormation template.